All right. Hello and welcome to Coding Out Loud episode 2. Thank you so much for joining me and my co host Holly today. And today we're going to create a table. Starting with a sketch that Holly made. But before we get there, I want to start with a couple logistics. First of all, if you would like to follow along with us, you can do so at bit.ly/coding out loud. And you should be able to see links for episode 2 there, including a link to an RStudio Cloud project where you can kind of pick things up and get started, or go and see the source on GitHub and download our Markdown file that we're going to use for the project. And before we start coding out loud, let me introduce you to Holly. Holly, would you like to introduce yourself?
Yeah, sure. Hello everyone. My name is Holly Cui, and I'm so excited to join our second session of Coding Out Loud. And I'm currently a junior at Duke University, and my major is statistical science with a data science concentration and a CS minor.
Great. So Holly was in my data visualization course last semester and did some fantastic work there. And I asked her to join me here today. And in order to prepare for this, what we did was to take a look at some of the publicly available data sets that were, made available sometime over the last year. And looking at the Tidy Tuesday projects data set, the one thing that jumped out to Holly was the makeup shades data. So that's what we're going to actually work with. And for those of you who have seen this data set before, this should feel quite familiar. But if you haven't, if you go to the README for our project, and then also look in our Markdown file for this project, you should be able to kind of see what our data looks like. And let me also pull up, before we get there, on the Tidy Tuesday page, the makeup shades data, so that we can take a look at what kind of the background of our data is. So the data set actually comes from the pudding, and they had a corresponding article to accompany this data set that takes a look at the colors used in various makeup shades, and also does an analysis of what they call to be either natural or nude colors. And kind of we can see, if you read through this really well written article, you'll see that there's a lot of bias in the language here in terms of what sort of skin colors are being mapped to the names like natural and nude. So we are going to be working with this data set. And in preparation, Holly took a look at the kind of the data dictionary and created a sketch for us for what we want to create. And we're going to take a look to see if we can attain this sketch in the next hour. So let me pull up the sketch. And Holly, do you want to kind of tell us about how you came up with this idea of what we want to create today?
Yeah, for our data set today, we're trying to make a comparison table, including several of the top foundation products from different brands. And the idea is to help the customers compare the color shades of different products and make the picking easier. And so we can see from the table, the first column is the brand, or maybe we can group by the product later because it will be
Mm-hmm.
easier. And for the second column, we want to, for each product, we make like a shade bar or a color scale bar that can shows the transition of the colors. And below that, we also want to put the number assigned to each shade so that it will be easier for the customers to see which color they want to pick when they want to buy it later. And then for the rest of it, we also want to include whether the color is numbered from light to dark. And for the rest of the two columns, we have the natural shades, which later we may or may not include them because we want to mark what shades are somewhat like have the keywords natural or nude in their shades name.
All right, so let's take a look at the data and see if it's feasible for us to make such a table. I like this idea of starting with a sketch a lot, even if we may not get to the ultimate sketch at the end, particularly because it gives us a roadmap that we can always come back to. And usually when I make a sketch like this, about halfway I realize, I was either over ambitious or this is not really what the data is about. And we're going to find out in this case if we're able to make something like this. But what I have in the back of my mind looking at this sketch is that ultimately we're going to make a table. But in order to be able to make a table, we're going to start with our raw data, take a look to see which of the variables we're going to use as is, and which of them we might use kind of compute other variables on. So I'm going to open up my R Markdown file called Makeup Shades. And let's go ahead and load the two packages that I know I'm going to use, the tidyverse and the here package. And then let's go ahead and load our data. And let's take a look at our data. So in this all numbers data set, we have the brand that the makeup, the foundation comes from, the name of the product, and then another name. And so maybe referring back to the um, data set will help. The data dictionary will help here. So the name is the programmatically extracted word-based name of this particular shade. So that's where we're going to look for that keyword natural or nude. Then there's some other information about the specific ID and the lightness and a hex color that I think you wanted to use, Holly. Is that right?
Yes, we can match the
Yeah.
hex color with the color bar we want to recreate later.
Okay. And then there's this light to dark, which is like a true false variable on whether this product line organizes their colors from light to dark. And we may want to limit our analysis to the ones who does because we want to calculate some percentiles. So if you'd like to follow along with us as we go, the best place to land in is bit.ly/coding-out-loud. And that should have all of the links you need for getting started on our Studio Cloud or grabbing the starter source code on GitHub. Okay, so we have our sketch. Let's start to try to recreate the basics of the sketch to begin with. So the first thing that I might want to do is insert an R chunk. And let's start with our all numbers data set. And then which variables might we want to look at? So we said we maybe want to group by product, right? Because each product appears multiple times depending on how many shades they have. So our ultimate table, we want it to be grouped by product. And then if we take a look at the first column of your sketch, we need instead of the brand, I think we decided we want to do product name. And then let's try to grab all of the hex colors. So let's start with that, okay? Grabbing the codes of the hex colors, and then we'll think about converting them to shades a little bit later. So how might I want to do that? Grabbing the hex colors and maybe creating one row per product where I have the hex colors maybe comma separated in a cell for that particular product. We were going to want to use like a mutate or a summarize. With mutate, we're going to end up with the same number of rows as we start with, but with summarize, we can end up with the number of groups we have, and that sounds like kind of what we want, right? So let's go ahead and say summarize, and maybe we want to call this something like shades. And we might want to say, create a character string that has all the shades in a given cell for me. So one function that I like using for stringing things along in that way is, so we're trying to collapse a bunch of character strings, is the glue collapse function from the glue package. So let's go ahead and add that package. And we are going to get the hex colors. And let's see what that gives us. So we can see that we have the name of the product and then the hex colors for that, however many occurrences there were of that product are kind of collapsed into a character string. But we might want to separate these with commas or something. So let's take a look at the help for glue collapse. What argument might be helpful here? Maybe the sep? Shall we give that a try?
Yeah, let's try that.
All right, so let's say sep. So now I actually have a column with the shades, and then they're comma separated that we can see. Some of these have only one occurrence, but many of them have multiple occurrences, and we have 145 products, okay?
Oh.
Now, in this sketch that you showed me, one of the things I'm seeing is that you want the colors to be kind of ordered from light to dark. Is that correct?
Yes.
So we probably want to make sure that in this character string, they're in that order from light to dark. And I have no idea if they are right now, just looking at these colors. But if we take a look at the our data set, our raw data set, these numbers are basically the order in which the producer offers their product, right? So these correspond to like the numbers they give to their products. Is that correct?
Yeah, I also noticed that. So maybe right now is ordered in the way that we want.
Yeah, it very well might be because these seem to be in order, right? This numbers
Yes.
column seems to be in order, but just in case, because I'm not sure if it is throughout the entire data set, I am going to say, let's arrange by the numbers column and then collapse in that order. It very well may have been the default, but I'm not sure. The other thing we want to do is, so that's, we have our column 1 and column 2, except not in the colors, but we have a version of our column 2. And then the other thing that we want to do is we want to get that light to dark column. That's in our data set too, right?
Yes.
So let's go ahead and bring that in as well, except we want it to appear just once per product. So as opposed to repeated multiple times per product, we want it to appear just once per product. So perhaps something we can do in this summarize is light to dark, and then give me the unique values of that light to dark variable from the data set. So now we have our column 1, column 2, and column 3 of our of the table that you sketched out. Sound good?
Yes, but right now I see there are NAs in the light to dark column.
Yeah. We probably don't want those, right?
Yeah.
Yeah. And in fact, I think that given the definition of that light to dark variable, whether this product line organizes their colors from light to dark, I think the only ones we do want in our table are the products that are in that order, because we're going to have to do those calculations. So how about we filter? So how about we filter for where light to dark is true? And if it's going to all show true, do you think maybe we can omit that from your sketch?
Yes.
What do you think? Like maybe ultimately what we end up with is like maybe we just don't have this column ultimately.
Mm-hmm.
if it's all going to be trues.
Mm-hmm.
We can keep it around for now, but I'm thinking that maybe we're going to use that to filter our data instead of expose it. So the first three columns, it's like from your original sketch we have, um, but we need to think about the rest. So tell me a bit about what we wanted to do with the natural shade. You were talking about the names of the colors.
Yes, so I want to find all the shades that has the keywords natural or nude or neutral in their names so that we can get a sense of which shades are considered as natural, and that will be easier to help the customers find which shades they want.
Okay, so then, um, well, maybe this feels like a little bit cheating me, but we don't have to do everything in a single pipeline. I'm going to call this our first three columns and save it away. And then let's tackle this natural or nude or these keyword situation that you were talking about. So let's go ahead and say we're going to create a new R chunk. So maybe here I'll add some notes. Create the first three columns of the table, and then the next task we want to tackle is extract natural, nude, etc. info from name, right? Color name. Okay, so for that, we're going to go back to that name column. So over here, look at all these interesting color names. Amazing is a color name. Apricot beige is another column name. Very interesting. But let's take a look at some of the things that might show up. So you said natural. So if I do natural, it looks like I have 48 of these that have the word natural. What about like nature? Is that a thing? No. What other keywords were you thinking about?
Neutral.
Neutral. Okay, let's take a look at that. Right, so neutral. And we can see like some of these are starting with uh, um, uppercase, so we're going to want to keep that in mind. And then there was another, so do you want to go for natural and neutral? Are there any other keywords we want to look for?
Mm,
What about that nude?
yes.
Yeah, so maybe we think about those three. What do you think?
Yeah, I think that sounds good.
So we're looking for natural, neutral, and nude. And we're going to want to do this such that we can capture both like the uppercase and the lowercase, just in case, because I'm not really sure exactly how they're spelled in each of the entries. So let's start with our all numbers data set. And then let's create a new column that's like that tells us whether it's included. How about like is natural, maybe natural shade, since it'll be a true false. And then what we want to do is we want to say, do you see these character strings in the name variable? So what sort of a function might we look for those character strings?
I'm thinking about something like contains or where, like that.
Right. So we want something to look in the like in the character strings, right? Whether it's there or not. But contains is something we can use on column names. So that's a dplyr verb that we can use on column names. But in this case, since we want to actually look in the character strings, we're probably going to want to use something from stringr. So how about something like str detect? If you detect it, give us a true. Does that maybe do the right thing? Let's take a look. I like looking at the example. So if here's the example, fruit is a vector that has these, and then it tells me, give me a true if it contains the letter A, and each of these give a true, or give me a true if it contains the letter B, and only one of them gives a true. So this is the sort of thing we want with trues and falses. So let's look in the name column for some of these character strings. And do we want each of these to occur, or either natural or neutral or nude? What do you think? Or, right? So let's maybe go with an or. Will this actually work? Well, it did something, huh? So whenever I'm like, I'm not sure if it actually worked, I like popping the viewer like this. And
Yes.
then, in fact, something we might do is say, relocate the two columns that we're like dealing with, the name and the one that we just calculated, so that they're at the beginning. So porcelain and pearl, those are false. That looks right. Let's sort on this. And then the trues are indeed the things that seem to have natural and stuff like that in it. So this looks to me like we got what we wanted.
Mhm.
And now that I've confirmed that, I can get rid of like these, relocating the columns and popping them into the viewer. One of the questions that came up was, how are we sourcing the example code into the console? So if you just highlight it and then do Command Enter, you don't have to copy and paste it. It'll just send it to the console. So we have these, now we know whether a color is like labeled as natural, neutral, or nude. But what we wanted to do was to identify where in the spectrum for the offerings of that product that one falls, right? So how about
Yeah.
we create a data set that basically gives us, these are the natural, or let's just call it natural for simplicity, natural colors. And it basically could mean any of these. So how about we filter for where natural shade is actually included, okay? And we actually want, we said we only want the observations where the light to dark scheme is true. So these are for each of the products. These are the product offerings that have the word natural or something like that in its name. And I think you wanted to calculate the number associated with natural for that shade, right?
Yes. Or maybe we can
What?
calculate the average if we have multiple for one product.
Right. Right. That's a great point, because I think what we're seeing here is that it's not just one of their offerings. Shades has the natural in it. So when we sort by product, see, we can see multiple things that are called natural. So you're suggesting maybe we take the average of the number? I
Yeah.
think that,
Right now, I
yeah.
think it may
Yeah.
work.
Mm-hmm. I think that sounds reasonable. So basically, let's calculate a marker for natural for each of the products. And since we're saying for each of the products, what do we need to do before we calculate that mean? We're going to want to group by. Group by, what are we grouping by? Product?
Product. I
Is that
think there
right?
is another column called ID if that is easier to use because it's also
Oh, yeah.
yeah,
Yeah.
each assigned to
I think if they're the same, either way is fine.
yeah.
So we can do, yeah, that's a good point. If we had to type out product names, I think ID would be a great one to go with so that we
Mhm.
wouldn't have to type all the long names. So
Yeah.
let's group by product, and then we want to calculate the average number per product because these are only the ones that have the natural. So that's a summarize.
ID.
Um, Maybe shall we call it like natural number or something? And then that'll be the mean of the numbers. So here we go. So for each of the products, now we have a measure or a value for what's considered natural in that product line. Does that
That
sound
looks
good?
yeah.
And
Oh,
is
I'm
that
sorry.
basically what you wanted to have in this fourth column?
Yeah, that basically achieves what I want. But right now I
Okay.
have questions about this. So we only have some of the rows being filled while others because we only see like 30 rows having the natural keywords.
Mm-hmm.
So maybe we cannot fully fill the columns, which is
Yeah. Yeah. So I think you're right that, not all of this information is available for each of the products that were in our original data set. So then I think we get to make a decision. Either we say, this is a table where we're only going to include a particular product if we have full information on them, or we say we include all of the products and then have some NAs in our um,
yes.
table. I'm going to suggest let's just go with the ones where we have full info because if this is supposed to be
Mhm.
informative for a particular right selection process, if it's going to have an A's in it, then it's not that informative.
Yeah.
Okay, so we have now calculated the natural shade. So let's, maybe this is like the marker for what a natural is considered. So I'm going to call it that. And so we have this data set saved as well. And we still have another column that we want to calculate. So calculate the percentiles. Let's go ahead and insert another chunk. And since we said we're just going to start with these as our the final table we're making is just the ones that are included, the products that are included here, right? Okay, then we start with this as our starting point. And then we can bring in information about these products from the all numbers data set, which is our original data set. So now for a, now basically we've brought in any sort of information that matches these products, I think. And now what do we want to do? We want to calculate what percent of the shades are below the natural. Is that what we wanted to do in this last column?
Yes. Yeah, I want to put the number we just calculated as a marker or a
Mm-hmm.
cutoff point so that we can calculate like how many percentage of other shades are below the natural or how many are above. Yes.
Okay. Okay, that sounds good. All right. So then let's think about how we join these data. So my natural marker data set has 41 rows. My all numbers data set has 3,000 something rows. And if I look at the names in my natural marker data set, I have product and natural number. And if I look at the names in my all numbers data set, I have product is one of them. So they must be being joined by product. But whenever I do these joins, I really just like prefer to be explicit. So it's like clear how something is being included, even though it will probably give me the exact same answer. And really what we want is go back to our original data set and only select the products for which we have this information.
Yeah.
So I think that even though it might give the same answers, it might be better to start with our like raw data and then say if something is both in all numbers and in natural marker, keep it. I think we're literally arriving at the same answer, but I was thinking that it's like unclear to me how we were getting at that number. And now I feel a little bit better about that.
Mhm.
So we have our data set that has like 968 observations. And we want to calculate these percentiles. How do we want to go about that? What do you think?
I'm thinking about maybe we can first find the maximum or the minimum of each product's shades number and then approach through that way.
Okay, so let's take a look at the maximum or the minimum and then figure out where the what the percentile what percent of those fall below a particular one. Maybe. Let's take a look. So I'm going to try to take a look at the raw data so we can think through it. So let's imagine that we're only dealing with this first product, okay? Full filter one. There are how many of these that have that name? There are 30 different shades for fall filter. And the numbers range from 100 to, what does it look like? 550, right?
Yes. I think it's
And
covered by our videos.
oh, okay, okay, you can't, yeah, so here, it should be, it's going all the way down to 550. I see you're not seeing exactly that point in my screen. And let's also look at the natural marker for that particular product. So fall filter, just so we can take a look at, oh, that's not in our data set. Okay, let's pick one that is in our data set. 10-hour wear perfect foundation. How about that? Okay, there are 60 of these. And in our natural, the number associated that we have calculated for natural is 24. So how are we going to use that information to calculate that percentile that you wanted here?
Maybe we can use like a comparison.
Mm-hmm.
And first we get how many total numbers of shades for each product, and then we choose those that has smaller numbers than the one we calculated
Okay.
and divide it by it.
Okay, so here that number would be 60 for the first thing. So we need a way to calculate that programmatically. And then you said smaller than so 24, and we should probably do equal to or smaller than for the
Yeah.
definition of a percentile, right? So that's 24. So 24 of these have values equal to or less than the median. So the percentile for this to be calculated would be 40%, right?
Yeah.
Okay. All right. So let's try to go ahead and do that. So that this way we kind of like have solved our problem for one of them, and we can now write the code, and then we can check ourselves to make sure we're doing it correctly. Okay. So we want to do things at the product level. So group by product. And then we want to calculate, first of all, we said we want to know for any given shade, is it at its median level or is it lower, right? Or is it at its natural level or is it lower? So we can create like a new column that will give us like a true or a false. So maybe at or below natural could be something like if the numbers column, numbers value for that is less than or equal to the natural, what did we call that number? Natural number. Okay. Let's view this to see if we're doing things correctly. For a given product, 10-hour perfect foundation, natural number is 24. If the number is 3, it's true. If it's bigger than 24, it's false. So that's what we wanted. Okay. And then we want to calculate how many times that product shows up. So let's say, like, give me the count. So n is equal to like the row numbers for that particular product. So I'm going to use this n function from dplyr for doing that. That should give me 60 for this first one that we were looking at. That gives me 60.
Yeah.
And then we want to say, give me the percentile or the proportion. So something like proportion at below natural is going to, we're trying to get to that thing we calculated, the 24 over 60. So that would be sum of these at below naturals divided by the sample size, right?
Yeah.
Right, so we got that 40% that we calculated for that first one, right?
Yeah.
And then, okay, so we have that, except the thing is like we lost everything else. We had some other information that we lost. So that's the thing with summarize, because we're grouping by, and then we're calculating some new things. It gives us those, but we lost kind of everything else that we needed, but that's okay. We'll maybe like bring them together. So how about we call this like last column?
Yeah, then we can
This is like,
join them back.
yeah, we'll like join them all together. Basically stitch the table up together. Okay. So let's go ahead and put it all together maybe. So we have our first three. And then we want to do like a join, I don't know, some sort of join. I can't think, but we're going to want to do some sort of join with the last column, right? And so let's take a look at what we want to do. Names in the first three columns is product, shades, and light to dark. names, and the last column is product or prop N or prop at below natural. Maybe these are like last two, not just last, because we're probably going to want N and the percentage.
And, yes.
Yeah. Okay, so let's rename that. And we probably just want since we said we don't want any NAs in our table, like anything that we can fill in the full information for. So we want to join that will give us the intersection of these two. Which one was that? The inner join.
Inner join, yeah.
Okay. And because I get confused, even though this may be obvious to others, we're going to leave the by here. Oh, what do you not want? Like? There we go. Okay. So we have product, we have our shades, which we are going to still need to turn to colors. We have the light to dark. We have an N, which you didn't have in your original sketch, but I added because I just feel like when we report some sort of percentile, it's just useful to give some sense of the sample size. Maybe that's like the statistician and me coming up, but that's like what my gut tells me to do. And then that percentile. And remember, in our table, that light to dark column is all trues. So how about we get rid of it? What do you think?
Yeah, that sounds good.
Yeah. I mean,
right now it's non-informative.
Yeah. All right, here we go. So here are 5 columns. We have a table. It looks like something, but it doesn't look like your pretty sketch, but we have it, right? So our next task is going to be, how do we take this information that is in this data frame and actually embellish it a bit? So we have everything we need, but we are going to want to change things up so that it looks more like your table, right? So to improve the table, what package shall we use for this table?
It's the GT package.
I think so. Yeah. I mean, ultimately, we're going to make an HTML table. We didn't come in with a desire to make something like for PDF or whatever. And those hex colors will hopefully display nicely in a GT table. Okay. So let's go ahead and load the GT package too. I'm going to go scroll all the way up and add library GT. And then scroll down. We're starting with our shades table. Whoops. Something I just like to do when I'm using GT is like, just give me the table. Let's take a look at what it looks like. And then we can go from there. Okay. And maybe let's zoom in.
Yeah.
I mean, this looks terrible, but it has the same essence of what you wanted to do without any of the artistic things happening. Okay. All right. All right. So what we want is we want R to understand that these are hex codes, right? And then show us the shades associated with those. Okay. So one way I'm thinking of doing this is right now that shades column is just a single character string. So we want to be able to apply some function to each of these hex codes individually and convert them to color swatches. So when they're in this like single character string, it's not even a list column, just a character string. That's not going to be easy to do. So I am going to actually first expand this table where each row is a shade, kind of going back almost back to that all numbers table that we had, and then apply a function that converts the hex codes to color swatches and then collapse things back again. Okay? There may be other ways of doing this, but that's one way I can think of doing it. So we're going to use a really handy function called separate rows.
Does this function automatically separate the rows, or should we specify something?
Yeah, so I think let's take a look. I bet it automatically separates. Look, it does automatically separate, but do you understand how it separates? Like to me, that I could do one of two things. I could try to understand that, or I could say, let me tell you how I want you to separate it. And I think that's what I'm going to do, right? Okay. And so in our table, we had like a comma and a space separating things. So how about we do the same thing here? And I am going to get just run these first two lines here. So now we have one shade per
Oh.
row. So our products are, we're back to those 968 rows, but now we can operate on the shades individually. Okay. So the nice thing about hex codes is that if we can convert this to HTML, like if we can tell assume this column is HTML, it will actually understand what that is and then use the colors for us. And I think, if I remember correctly, the GT package, look at its reference, has an HTML function. So it has some HTML function that we should be able to use at some point in our analysis, in our like table making. Okay. In this case, they use the HTML function to turn this table header into italics, but we're going to want to use it to say, take this and like use it as the text color. So I am going to suggest that we actually construct the HTML ourselves. And what I'm about to say next does require knowing a little bit of HTML, which I think like I'll kind of like walk you through it. But it's something I generally have to look up, like how do you change the color of a text in HTML or something like that. Do you ever write any HTML code, Holly?
No, I don't think I have any experience.
Yeah, okay. I do because I try to change colors of things on my slides or websites. That's the only reason why I do it. So let's create a new or let's basically work with this shades column. And what I'm going to do is I'm going to add some text around this to turn this into like an HTML statement, basically. Okay, so we're going to want to create this as a character string. And generally, when I'm creating character strings, I like using the glue function. So I'm going to do that. And let's look up something like HTML change color of text. So we want to do something like, we're going to want to do something like this. Except not background color, but just text color. Here we go. So we're going to want to construct something like this, except instead of the color blue, we're going to use whatever hex code we have in the column. Does that make sense?
Yeah.
Okay. All right. So let's construct a character string where we're going to create a span. And then what was it? Style equals, and then I think it had something like color. And then I needed to, they had blue, but I'm going to have to put something else in there, our hex color. And then we can add like whatever text we want it to represent with, and then close the span basically. And so this should be whatever we have in our shades column. So what happens if we do this? So it creates basically a new column for us. Select this just so we can see what it looks like. Shades, sorry. So it basically creates something like this. You see some HTML constructed text where the color will be this, and then the text will be this as well. Though I'm seeing these escapes, we may or may not need to worry about them later. I'm not sure just yet, whether it's just showing it to me to escape these quotation marks or if it's something I'm going to need to worry about. Okay? So next, let's go ahead and maybe pass this on to GT just to see what it looks like there. So I think it's stuck. All right, let's give it a second to. Come on, you can do it. Okay. All right. So next what I want to do is basically tell GT to format this column as HTML. Do you see how like it's just showing me the text? I don't want that. I want it to actually understand that that is HTML code and interpret it as HTML code. So in order to do that, we're going to say format the column called shades, and the function that we wanted to apply is that HTML function. So I'm going to say take the, let's write a function, and we'll say map over this HTML function that it has. And GT should be above this. See if this will work. I'm saying take that column and map over it the HTML function. Well, it did something, but I don't necessarily think it did what we wanted it to do, huh? Okay, so right now it's not showing anything. How about we give it a different character? So maybe I'm going to say, instead of showing this shades, how about we give it as like a square or something like that? Okay. So that it looks like a little swatch.
Yeah.
Something like this.
Yeah, that makes more sense.
So it's still not showing me anything in the shades column, but hopefully we're getting there. Let's take a look. So we wanted to apply it to the shades column. And also right now we have something that's different than what you had. We still have our data across many rows, huh? But you wanted the shades to be next to each other.
Yeah.
Right? So let's go ahead and bring them back. Let's go ahead and actually say, after we have added this, let's do a summarize. And I'll write over that column again and basically collapse things back together. So maybe blue shades. What would this give me? Named argument. Or maybe that's glue collapse. but we need it to be grouped by the product. Right now it put everything together. Maybe that was our issue earlier too. Okay, so let's see if this is what I want, and then accordingly we can pass it on to GT. So we have a product, and then we have basically these HTML codes for each of them, right?
Yeah.
Okay. However, I lost my other columns that I needed, so let's bring those back as well. So we really want to group these by all of the variables that we wanted. So that's product and prop at below natural. So now we have all of the columns that we want to bring into GT. And if we take a look at this column, do you see how at the end there's like something weird, like a ampersand and a G? I wonder if that's messing things up when I hover over it. Let's do something else here. And before we construct these strings, let's clean up that column. Do an str trim on shades to get rid of any additional spaces or anything that might be there. I'm still seeing that.
Yeah.
And summarize is giving me that pesky error. So how about we say drop the groups. Coming upon time. Let's see if we'll be able to do this. All right. I wonder if this is maybe not what I want. What if I just do maybe something like this? Okay, that looks like that did it. So we have separated, and I'm not seeing those weird ampersand G's anymore. Do we want to be brave and try to see if this will work?
Let's give it a try.
Let's give it a try. Oh, it is still not doing it. I wonder what the issue might be with the HTML. Is that there's a missing close. Yes, so I think maybe we are missing something here. Very good. Thank you so much. Okay, the chat came to the rescue. So we basically have kind of what we were hoping to get out of this, but they're in the wrong order. So let's help with that. Thank you so much for the help, HTML help in the chat. So we want to relocate. We want to start with the product and then shades and then the other things, right? And then maybe we can do like a little bit better and say format percent. So this prop at below natural, maybe make it 2 digits. Oh, decimals, sorry. Here we go. That looks a little bit better. So if we had a little bit more time, what we could do is we could relabel the column headings perhaps, just to make them look a little bit nicer. We could think about aligning the shades column a bit differently if we wanted, maybe left align them. We could think about adding more embellishments to our table, but we were at least able to get to the point where we started with your sketch and got pretty close to what you had envisioned to begin with, which seemed pretty sweet.
Yes, I'm really impressed.
Yeah, this is great. So that was a great idea. And hopefully, thinking about how this would help purchasers, like maybe this is the sort of information that would be helpful in selecting the sort of product line you want to look at.
Yeah, and maybe for future things, we can also mark the natural cutoff point onto the shades kind of like the scale
Oh,
things, yeah, it will be
right.
easier.
Yeah, that's a really good idea. And that could almost get us back to that analysis that was done that motivated this data set in terms of where natural falls for these brands. Great. Well, thank you, Holly, so much for joining me today. And thank you
Thank
for
you so
your kind of original idea for what we tried to accomplish. And thanks to everyone in the chat, and especially for the last minute HTML help that saved us. And we're going to be back with episode 3 in a couple weeks with Lily Clark. And until then, enjoy. And I will push all of this stuff that we created into the GitHub repo. So if you want to pick things up where we left off and practice on your own, you can do that. Have a good rest of your day. Bye, Holly.
Bye. Thank you.
Mm-hmm.